Bene, qualcuno mi può proponermi... sorry, can someone... okay, so how do I create this .sh file? What did you write in your program? Okay. I prefer giving explicit names. Allora, in bash, sì, giusto. Aspetta. Or, like, is it something that we've learned? Minus. Yeah, I mean, there are many ways of using. Yeah, okay, so. Interactive. Yeah. Okay, so just because, I think we have to use what we've learned this morning. So we learned just like a few uses of awk and one use of sed. So for which part do we want to... And also we've learned the idea of piping, so pipelines. So we're going to we're going to chain a few commands. And we might as well follow, so the instructions are telling you to remove the quality score. So as a refresher, that was so this FNR that e qui ci sarebbero i file FastQ. Basta. Ok, se voglio recuperare il prompt, if I want to get the prompt back, I can do a keyboard interrupt, and I do this by pressing Control C. Okay, but okay, I'll just copy paste this out of convenience, and I'll go back into my .sh file converter. Oops, I'm missing the A. So the output of this... Yeah. Yes. Good point. Yeah, one at a time. Even if... Oh, so maybe... Actually, in this case, I don't need the F, since I'm doing it file by file. Maybe... Yeah. No, but we are removing all the multiples of 4. Yeah, it's NR modulus 4. Yeah. I mean, we'll try it anyway, and if we break it, that's life. And then it's not enough. We also want to remove another line, right? Yeah, sorry, I get this color highlighting with red, which I know is not projecting very well. Okay, so the input is the output of the previous command. That's fine. And finally, what do I use to replace a given character by another? Sed, yes. And that's going to be replacing at with greater than everywhere in the file. And if I leave it this way, standard output will just be out there in the terminal. So maybe I want to save this into a file. So, I'll just type, file.fasta. Done. Let's try it. So bash converter.sh. Okay, so I see. So I have a bunch of .fastq.fasta files because that was the full file name, and it appended .fasta. That doesn't prevent us from checking the content of it. So let's take a look at the head of the first one, for example, here. Oh, I think but you know, at least in spirit, it looks like what we were expecting. Like the FASTA format is defined this way. So there are only 2 lines per sequence. Even though I've noticed that very often in the FASTA format, they cut out. So for example, here there's a line break, and the rest of the sequence is on another line. So maybe I shouldn't say 2 lines per sequence, but let's say 2 entries or 2 rows, in speaking in tabular data language. So one thing we can use is a Unix command called base name. So when you know a file extension in advance, so for example, to get the base name of this fastq file, I just specify the expected extension, and it, fastq, and it will return just the file name without the file extension. So the way you can plug this, so basically we're interested in this output, right? So this command looks useful, and we want to plug it into our existing pipeline. So one way to do it here would be to replace file with an expression. So basically base name of file, where we specify that the extension to take out is fastq. So here, I don't know if it answers your question that you had earlier, but it, you know, we are kind of reusing this variable inside of you know, this becomes a variable itself once it's evaluated. So, you know, bash will first evaluate what's inside the parenthesis by using this file variable. But maybe you had like another question.
It's not the output, it's not file in that moment, it's the variable file, what was in it at the beginning. But it's
like, does it still exist here? Is that what you mean, or?
I mean that if you play with file inside the pipe,
Yeah.
but you do not save file, you only use it and you don't save it anywhere. You only call that output without putting anything, right?
Yeah.
And if you want to use it by calling it, there is no instruction, but actually we just learned awk, and with awk you don't need any, there's no way that you need to use it, to call it explicitly anyway.
Yeah.
Because
Yeah.
does all the
Yeah.
You could possibly manage it.
Okay, so yeah, I think I misunderstood your question because I thought it, so we're not going to do it today, but like there's the whole consideration to be made about scopes and where do variable lives.
Yeah,
so for example,
exactly.
but yeah, so for example, you know, the file variable here it exists, it's defined for this for loop, and that's it. Yeah, but yeah, we're not covering this today. Okay, so let's try this now. Let's run bash, and now let's check our outputs. Oh, okay, this looks better. And I can control. Yeah, it looks like. Yeah, so I'm not sure the ends of the files are actual sequences. They don't look like some, but yeah, the start of the file looks like a FASTA file. And so I will not spend much time on it at all, but for the people who are bioinformaticians, wait, no, maybe I should open it in Chrome. I just wanted to mention, it happens to be a project I'm working on, so I'm interested in improving it. So Plotly is a company that does web-based visualizations. They came up with a web app framework called Dash. So let me visit a gallery of Dash apps for you. And they're targeted at the scientific world. Plotly.host. Yeah, so there are a bunch of dashboards in a bunch of fields. And if we look for bioinformatics, there's something called a sequence viewer. And, okay, so let me actually copy one of these files over to one of these files that we just produced. Okay, let's say this one, the last one. I need it online because I'm going to upload it from what I have access to. So just a little refresher on secure copy, SCP, hpc2.unitn.it bash lesson data, and copy it over here in my home. Password. Okay, it's there. So let me, so basically, not being a bioinformatician, I'm not really convinced of the value of such an app, but now that we have a FASTA file, and I know this this app is meant for FASTA files. See, download sample data fast, so there's an example data set, but if we, yeah, let's pick this guy. Yes, see, so basically I'm retrieving the metadata here. So this identification and, we recognize length, maybe it's too small, I don't know, length 101. And to be honest, I'm not sure what to do with this because I'm not a bioinformatician again. I think, yeah, so you can select a part of the sequence interactively like this and graphically. So we're not in the command line interface world at all. That's like the opposite. It's completely graphical. And again, I don't speak this language of amino acids and nucleotides, but basically that's the kind of apps that I work very little on it, but I contribute to maintaining, etc. So if real people do real bioinformatics, I'm actually interested in hearing what they think of it, if it's useful at all, etc. That's it for FASTA files. Now that we have actually we have two programs, right? Because we have two .sh files, demo.sh and converter.sh. We're going to worry about the future of these files. So, it's one thing to have written them and run them, and we haven't tested that very thoroughly, but it seems to be doing okay. It seems to be doing the task that we want them to be doing. But a more rigorous way to keep track of these programs and possible modifications that we will do to them, or that a collaborator of ours will do to them, is to use version control. I'll show you, to make you laugh, I will show you a cartoon. Do you know PhD comics? Is it still in fashion? In my time it was. Software carpentry, listen. I think it's this cartoon, because I think we can all relate to it. So, you know, the student is trying to write the final version of their paper. Of course, they get feedback from the advisor, and it's, you know, never good enough. And then the file name becomes incredibly convoluted and pretty dramatic over there. So basically, we want to avoid the situation. So, for example, if you know, if I was very well-intentioned and I was like, okay, what you typically want in a program is some information, documentation on how to use, because when you write it, maybe it looks very obvious to you, but later on, when you have to find it again, it will not be very trivial. And for example, you may not remember why you did this part. So maybe, you know, you want to be kind to yourself, to your future self, and you want to document that to be like, the command between is for removing FastQ extension. And maybe even at the very top, you know, you want to add, you know, extra comments, so like a title, description, things like that. But you know, now that I have commented my file, technically it's a different file. You know, it's a change I made to. So okay, let me actually not save it. So if you made changes but you don't want to save them in Vim, you go Q exclamation mark. So if I go like this, converter has not changed. It's not commented. But then let's say I want to make this commented version, so I'll go like cp converter commented converter .sh, and then what I'll edit will actually be this one. So I'll be like 1, 2, 3, 4 command between. And this one I save. And there's actually this very useful Unix command called diff, which, as the name suggests, returns a difference. So like the difference between comment and convert with respect to converter is that in the first one, we have this line addition. But basically, what I'm showing you manually here, so like creating another version of the file, checking what the difference between the two files are. Again, there's no reason to do it ourselves because we may forget things, we may make mistakes, and instead, if a program takes care of it for you, why not use it? So this program is called Git in our case. It's like the most popular by far version control system. There are older centralized version control systems, but I don't know, you're not old, so maybe you haven't used them. SVN, CVS, I think they were called. In very large companies, they're still in use. So I don't know if you get a job at a large company, maybe you will hear about these things. But nowadays, in software development, in modern companies, very often you will use Git. So Git will do this for you. You won't have to worry about it. And to introduce the so like conceptually, what you have to think about is an initial state of things. So let's say an initial file, our converter.ch file. And then instead of thinking of different files, you have to think of additions, changes. So maybe it's changing a character, maybe it's removing one line, maybe it's like removing 3 lines, etc. And the sequence of all these changes, you will think of them as playing. So it's like a film, a movie where you can like forward and go backwards. So maybe you're happier with an earlier version, so you will play the movie backwards. And whenever you decide you're happy with a given change set, so change set will be a set of changes, so given additions, given edits, and you decide to take a snapshot, an instant photography of the work, that's called a commit. Okay, so now you know the basic principle of Git and distributed version control systems in general. So let's get started. We're still connected to the HPC cluster, and we want to configure Git for ourselves. So like what Git will do is that whenever you're happy with like the advancement of your work, or it means something, like you've reached conceptual stage, you want a record, so the actual changes, when you did it and who did it. So to be aware of who did it, at some point it's like Git needs to know who the user is. So of course I'm going to write Marianne because that's my name, but like please write your own name. So so Git is the program in question. So Git is available. So we're going to configure it. Oh, what? Originally I was thinking of doing this locally, but I guess what? We can do it remotely as well. Yeah, okay. Git. Yeah, it's just that, for example, in my head I have the local language, so I was going to say, you know, here you're going to configure the username for your local machine. But obviously, if we're doing this on the HPC cluster, it's not on our local machine, it's on that remote system. So if I just signal it to me if I say local machine by mistake, because I'm used to teaching this lesson by running Git locally. So please write your own name, of course. Then, yeah.
If we already have an account with Git, should we do exactly our...
So do you mean an account with GitHub? Okay, yeah, so that's also important to distinguish Git and GitHub. So Git is a program, you see, that runs locally here. So at this point, there's no question of accounts. Okay. Here I'm configuring Git so that I can use it locally, but for the moment, there's nothing about online or storage. But your question is good, because later on, if time allows, but I think we will have time to do it, we will also use GitHub, which is an online hosting service for those Git tracked works. I don't. Sometimes universities have other hosting services, so you know, we're only using GitHub because it's very common. It's like easily accessible online. But I have to remind you that. Still, it's a private entity. Actually, it was acquired by Microsoft a couple years ago. So, in the
So, GitLab is
yeah, GitLab is one alternative. Bitbucket as well. Yeah, I can write them down. GitLab, Bitbucket. Or as I said, maybe within universities, maybe you have hosting services. So I don't want to make it sound too obvious, like, oh, just create an account on GitHub, because you know I have an account on GitHub. I use it for work, for personal stuff as well, etc. It's probably going to be very convenient to you as well. But if you have to be aware that it's still a commercial product. So for the first half of this lesson, until the coffee break, we're only going to use Git, which means that you know, it's a program here on the machine. There's nothing about any kind of online service, let alone commercial. It doesn't come into play. But after the break, when we start interacting remotely, so okay, here remote means two things, because you know, here we were used to calling remote the cluster, because here over at the cluster, you know, I'm not actually running programs and commands on my laptop. It's running on the cluster of the university, and here instead I'm connected locally to my machine. But yet another remote place can be not just the HPC cluster, but it can be, you know, the GitHub servers or the GitLab servers, or you know, any other server that's not your own machine. Yeah, I also maybe I'll point you to this. So if you don't have an account on GitHub, wait, is this? I think it's on the other page. yeah, if you don't have an account on GitHub, I'm not going to force you to create one. Definitely not, because it's not, it's not something I can require from you, because it's still your personal choice, and it's a kind of a privacy choice to create an account on GitHub or not. But at least you can do it in a way that you don't expose your email address. So we can discuss this more in detail during the coffee break. But if you already have an account, indeed, specify your, especially your email with the same one. Or if you haven't created a GitHub account yet, but you will during the coffee break, choosing to hide your email address or not, in any case, use the same email address that you intend to use later. So here we were specifying our username, and we're in the same way we're going to specify our email address. Well, you can always change it. Let's say you can also make a choice for the lesson of today, and tomorrow you can overwrite those configuration things, right? So it's not like a matter of life and death. Okay, now we don't have to worry about new line characters because we are on a Unix system, so it's all good, and the world is beautiful. If you were doing this Git configuration locally on a Windows machine, maybe you would have to beware of line endings. As I mentioned earlier this morning, when you write text in a file and you press enter to break the line and go to the next line, at the very end of the line, there's actually a character that means go to the next, that means end of the line. And sometimes the conventions for encoding those end of line characters are different, and they can create unexpected things. So it's all well referenced in the Git lesson by the carpentries that I can easily point you to. And again, here I'm following the content more or less because I see they have recent updates and little things that are not fully consistent, but anyway, I'm basing this lesson on the carpentry's material. And here you also get a chance to configure your favorite editor. So as you know, my favorite editor is Vim, but you could use Nano. So for example, you would go like core editor here. So I would leave it this way. This is Nano. This is the default anyway. But we can choose Nano for the lesson. And then when you run git config -- list, you get like a summary of everything you've specified. And so that's what Git, so globally on this system, throughout all the projects that you might be working on, every time you will make a commit, it will register it as, okay, this commit was made by this person associated with this email address. So I would like to, I'll go back to the root of, sorry, not the root, to my home. So I can go cd tilde pwd. Let's check that this is my home. Yes, indeed. And since we're discussing genomics, I thought that we could call our project genomics. So we're going to create a Git repository. So repository, sarebbe deposito. There's this idea of tracking and storing. So really, it's just a directory, and we know how to make a directory, right? It's a directory equipped with version control. So first, let's create a directory, and let's go into it. So as we expect, there's nothing yet in it. Let's use the A flag that we mentioned this morning. So from here, in relative, I can only just like either stay here or go one level up. Let me go back into genomics. And the way I make it not only a directory but a Git repository is by initiating a Git repository like this, Git init. So Git is very nice because it displays helpful and meaningful messages. It tells us that it just initialized an empty Git repository over here. And now when I when I run ls-a, I realize it's a bit different because in addition to the current and parent directory, I also have a .git subfolder. Let's look at it. Okay, and you don't have to worry too much about what's inside because precisely that's the whole magic. It's like instead of manually looking at the differences between two versions, Git will kind of do it for you. But basically what you have to know is that it will store everything related to the versioning will live in this .git subfolder. So don't remove it, don't go because otherwise you will lose the history. Here we're going to be working, creating files, maybe adding data sets. We're going to do a bunch of things. But when we make changes, we will record them, and Git will store all of that in this .git subfolder. We will not talk about branches today. I'm just anticipating. That's weird. Oh, maybe because, sorry, we haven't committed. We will talk about branches tomorrow with Alberto. Now so sorry, I forget what I just typed. The Git command that you will be running all the time is git status, because really that's what will give you the information about where we're at, what's happening, what's the status of my repository. So here you see that what's returned is that we are on branch master. So again, don't worry about it for today. Today we will only remain, the branch we will be on will always be master. And initial commit, so that would be like the starting point, but for now there's nothing to track and nothing to commit. Create copy files and use git add to track. So Git is really telling us the whole thing. We don't even need to follow a course. Let's put our converter.sh under version control, I would say. Or did I have something? Yeah. So where is it? Let's find it again. I think it was over there, right? So I'm just copying it over here. Maybe I could move it if I was really confident that you can just live here from now on, but why not copy it? And now when I run git status, I see that the returned message is a little different. We're still in branch master, but Git has detected that there is this file, which is untracked, at least for now. So if we want to start tracking it, we have to use git add. So git add will add the file to the tracking system. So let's follow along. Is it working for everyone? Git status now. I told you git status is really your best friend whenever you're versioning documents. So yeah, of course we're versioning code at the moment, but any text-based file will be suitable. So not the binary file. So actually the .doc document that we saw with the poor PhD comics student, that wouldn't apply because it's a binary file. So for example, if you go cat and something .doc, you won't be able to understand what the output says. But anything that's like a .txt, a .tech, if you write articles in LaTeX, for example, .rst, .md for Markdown, even small data sets like .csv files. All these things are both machine readable and human readable, so they're suitable for versioning. Since we've added converter.sh to the tracking system, now they're ready. They can be committed. So to commit them, we would go like git commit and specify a commit message with the M flag. And yeah, we'll write convert. So before I talk a little more about this new output that we're discovering here, I'll also mention that writing commit messages is a whole art. It's fascinating if you start diving into it. So they should be short, concise, but specific and descriptive at the same time. So it's a bit of a challenge because you don't want to put too much information in it, but not too little. But it also has the inverse quality that if you're really struggling to write a commit message, probably means that your commit is not meaningful itself, because what you want to commit is not necessarily a change that depends on its size, big or small. It has to be approached at the conceptual level. So it's like you want to add a particular feature. So for example, in our case, for example, yeah, the converter.sh file. Oh, actually, we could have started with that. You know, the earlier version of our program that had only $file instead of this parenthesis, this expression. Let's say that could have been our first commit, and then by adding this, that would be like conceptually one thing. It's like we are handling the file extension, but but if I only added base name and nothing afterwards, and something that would not even run, would not make sense, yes, it would be a change technically, but it wouldn't be a logical change in terms of I have reached another stage, in my building of my software. So commits have to be small enough, because if you have more granularity, it will always be easier to track the specific changes, especially if you break something, to go back. So you don't want to accumulate a lot of code. You don't want to have implemented like the data processing of all the files of different types. Maybe you want to handle one type of file at a time, etc. So remain small in the change sets so that you can easily describe them by a short, clear, descriptive commit message. And then in terms of the English, because I assume anyway people program mostly in English, so I usually use the imperative like this. And then we will see it in a moment, but this way when you read all the commit messages, it's like a story. So it's like even before diving into the code, if you're, let's say, you're the new student in the group, you will see a project and you can read the story of all the changes that you missed because you were not there before. And instead of just seeing variables and code that may look a bit daunting, you have this first approach of like following the development. Yeah.
Over here, when we say git commit -m, we don't mention the file name. How does the system know that?
Yeah, I'll come back to it, but it knows because it corresponds to what we added. So when you do git add, what you're doing by git add, you're telling Git, okay, in the next commit, that's what I want.
Okay.
So specifically in that moment, you're kind of, because in theory I could have maybe 10 files, you know, and maybe I'm modifying 3 files. So I want to git add those 3 files, and then when I commit, I know that these changes affecting those 3 files. And actually, you could also have made changes to 3 files, but only want to add in the next commit the changes regarding 2 files. So then you will only git add those 2 specific files, commit, then go back, maybe work a bit more on the 3rd file, get.
So the git add always has to come before the git commit.
Exactly, yeah. But we'll, I can even draw a diagram, we'll come back to it because it's a key piece of learning Git. Let's talk about commits in detail. So we see that, so when we take the snapshot, Git creates a commit here, which is identified with a hash here. It's repeating the commit message. So for example, you can use the command git show and this identifier to display what this commit exactly was about. So of course you don't type 7813, etc., right? Because in your case the hash generated by Git will be different. So you have to take to copy paste the one or type up the one that you see here equivalently. So here when I run git show, I see that, okay, first line, I realize that the commit ID or the git hash, so which uniquely identifies this commit, and I've never heard of colliding hashes, but you know, is like much longer. So basically, you know, this 7, 8, etc., or just the first few digits of here. So alternatively, I could have done like git show and this whole, the entire commit hash. And it's displaying the same thing. So author, so here you see the point in specifying, in configuring Git so that it knows who we are, who authored the commit, the specific date and time, the commit message, and here the actual content of the change, which in this case is like starting from nothing, dev null, and you know, adding this file with those line additions. And yeah, so here diff, you know, is the Unix command I mentioned earlier. Okay, need to log. So now if we run git status, still our best friend, we see that it's all clean. There's nothing to commit. The working directory is clean. The working directory being clean means that here where we're at in this Git repository, things haven't changed with respect to the latest commit. And how do I know what the latest commit was? There's also a very convenient command called git log. So it spits out the log of all the commits. So in this case, the last commit is also the first commit. There's only one, right? But soon enough, we'll make more. So actually, yeah, let's make changes to this file so we can get some action going on. It's always good to add comments in your code. You've probably heard this before. I'll just add one line for now. And now what happens when I run git status? Okay, I see that that this file, converter.sh, was modified but those changes were not staged for commit. So here, so if I type git commit, add a title, actually, it says no changes added to commit because I didn't add anything to. So it's actually called the staging area. I'll draw it over here. So here I'm working, writing those files. So that's the working directory. If I'm happy, or let's say if a given set of changes make sense, I will run git add to create a future layer for my storage. And then once I have everything that I'm sure I want to include in the repository, so for storage for good, then this I will git commit. And this becomes a stack because it's like the initial commit, the second commit, the third commit, etc. So this is called the working directory. This is called the staging area. And this is called the actual repository. So if I want this extra line to be included in the repository, first I have to specify that I'm staging it. And for this I use git add. Before using git add, actually, maybe I want to be a little more cautious, and I encourage you to do so by running git diff. So git diff is similar to the Unix diff command that I quickly showed earlier. So it tells us that this is the file in question, which has differences, changes, with respect to the previous commit. And specifically, so it shows a few lines. Actually, since the file is very short, it's like all the lines. But specifically what matters is this plus here. So this means addition of this line in particular. So git diff will always basically display you the difference that you have between the staging area, because this is not added yet, and the working directory. When you run git diff, you get like the difference, as diff indicates, between your working directory, which is not clean, as opposed to once everything is committed, we will find it again. But everything is clean and ready to. We're ready to loop over the git status, git work, git diff, git add, git commit, etc. So if we're happy with this addition. So let's say I made a typo, or maybe I want to add a period at the end of this. So maybe I'm not exactly happy with this change set. So I will further change it, and I will go like period. So I'll double check git diff. Now I'm happy. So I'm going to git add it. So now when I run git diff, I get nothing, because those changes have been staged, so they're over here. So now, there's no difference between the working directory and the staging area. Git status tells me that this modified file is ready to be committed, I may be happy with it and move along, or maybe I still have other related work to do. Maybe if this changes also impacts another file that I also want to update, maybe I'll update that file, I'll get added, and only when I'm fully happy with what I have here will I decide to commit. Okay, in this case I only have this one file, so let's say we're happy and I'll commit it. And the commit message will be add a descriptive sentence. Wait, I think, yeah, sorry, I wanted to show you something else right before we commit. I mean, if you have executed the commit, it's fine as well, but as much as git diff returns nothing, we may want to be interested in like double checking what is separating the staging area from the repository, and for this we use git diff with the option staged. Staged as it's staged but not committed yet. So here you can see this difference again. Now, if I commit, as I meant to do, add descriptive sentence. So again, now I'm familiar with it. There's this commit ID, the commit message, a summary of what was changed. In this case, one insertion means addition. And if I run git diff staged again, it returns nothing because now everything that was staged is additionally committed. It's in the repository. So there's nothing in a draft stage, there's nothing that's like living there that's not committed in the repository. And if I run git status, indeed, working directory clean, as I was saying earlier. Just as an aside, I will make you just think for 1 minute. What if in this Git repository, I wanted to also maybe collect some literature, some documents which are in the genomics theme. So maybe, I don't know, I wanted to save some notes. So maybe I would create docs or references, let's say. I would create a references subdirectory, move into it, and here, whatever, I would start writing, notes.txt, etc., because, we're doing research, so we always have in mind the paper that's coming up, not just the computations on the cluster. And I also wanted to version. Would that make any sense to do this? Why, according to you?
Within a repository, you're already doing version control within the folder, the main folder, so you can keep track of everything at the same time, unless you have other particular reasons.
Exactly. So yeah, the answer is twofold. So first of all, it's not necessary because everything, so since we have our .git subfolder here at the root of genomics, everything that's under genomics, unless otherwise specified, will be, you can add to the version control system. You can go like git add. So for example, when, so let's create an empty starting file. If I want to, I can go like git add references notes.txt. So I don't need, or if it's really separated and maybe in these notes I'm also collecting something related to another project, I'd better just get out of this repository altogether and create references outside. So when I'm back, here one level up, and then in this references directory, then I'll create a git init and I'll version it separately. But yeah, so the first part of the answer is that it's not necessary, and the second part is that it's even a little dangerous because the .git at one level and the .git at the level, in this case, they would collide. Like there could be collisions and confusions. Okay. This. Let's make yet another change to have a more substantial log, genomics. So for example, for now we have 2 commits, which is better than 1 and better than 0. I could have done this. But let's make yet another edit. Yeah, I could do. You can type up something else, of course, but still I'm trying to write good English and something meaningful in the context. So now if I save this and I run, git status or git diff, or in whichever order, but git status tells us that our working directory is not clean anymore. So what's in here does not match what's in there anymore. Before I added this line, it did, but now it doesn't anymore. So specifically, the difference is given by the git diff command, and it is about the converted sh file, and it is about inserting this line at the end of the file. Am I happy with it? Yes, I'll stage it. So git add, so I'll bring this this work over there. Git add convert.sh and git git diff returns nothing as expected because now these modifications are in the staging area. Yes.
Which is the command for pulling it out? The opposite of that. If I made it's added by mistake. I'm going to.
Yeah. So. Okay. Right afterwards, we're going to see how to go backwards. Yeah. So there. To remove it from the staging area. Yeah, because there's more than one way. So I'm trying, I don't know which is the more pedagogical way to, and even when I do it in my real engineering life, sometimes I use different ways. What I would do is git log. Okay. I was going to teach this in 1 second, so let's do it now. But yeah, let's pretend it's a mistake. That's a good example. So you have to say that you have to know that. So I'll represent all the commits like this as a tree. So let's say that was the initial commit. That's the second commit, the third commit, and we could associate the commit messages like when we display git log. for now we're only using the master branch, but like let's say tomorrow we'll see how we can branch off from here, but also from there, and anyway, so then you get a tree. Whatever, I'm not talking about branches today. So each commit has an ID, but it's like 7, 8, 2, 3, D, E, and you don't memorize them. That's not the point. By convention, the latest commit is referred to as head. That would be kind of like when we discussed. Well, we didn't really discuss them, but we reviewed absolute file paths and relative file paths in the tree of a Unix system. Here, similarly, you have, so actually I should write it on the other side maybe. So here you would have like the absolute, if you like, identifiers here that have, those crazy names, whatever. But you also have a relative way of referring to them, where the latest commit is head, the second to last commit is head -1. So this is the tilde symbol, but we spell it -1. And head -2, and so on. So as we will see, it's a lot more convenient to go like, okay, let's go back, 2 steps back, rather than, let's go back to 89A4, of course. So basically, here we were in the process of making, but it hasn't been made yet, the next commit, and we were not even, so we were at the staging area, we were not there, so this doesn't really exist anymore. So your question will boil down to, let's bring it back to head. So for this, you go, so now converter looks like this. But if you go check out, that's like the name of the command, head and converter. So now if I display cat converter, this line is not there anymore. And in terms of status, there's nothing. So I am back. So I was like on those like dashed line in the process of moving along that way. And I'm bringing it back to head over here.
Okay. And if I'm happy with the modification, but I do not want to commit them yet, but I already added it, is there a way to only keep it away from, remove it from stash without the modifications?
Do you mean the
modification?
Do you mean the staging area, or do you mean stash? Because I heard you say.
Area. Sorry.
Yeah, because that's something else, which is very useful, by the way. But okay, so now your other question is about, so we have added it to the staging area.
Yeah, I'm happy with the modification, but actually I want to do another commit on another file. So I just want to pull it back from the staging area, not to...
No, but in your case, what you would do is that you would keep working on the other stuff that you need to fix, be it even the same file, it doesn't matter. And then when you're happy, you would git add again and then commit. So actually, let's do it if you like. So let's say, okay, so I'll cheat by copying pasting, so it's a little faster. So what was the, okay, here. So vim converter.sh. Last line, I'm adding this. So git diff, I have this difference, and we're adding it to the staging area. So we're adding it, but we are not ready to commit. So for whatever reason, so either, actually, if you like, we could add another file, or we could just keep on working on converter as well. So I go like converter, and I'm like, maybe I want to spell it out with these instead of using this stenographic style, right?
Yeah.
So now I have a difference in the sense that, between the staging area and the working directory, which is what git diff returns, I have like, formerly I had this line. Well, so basically in the staging area, I have this line. And now in the working directory, I have that line. And if I'm happy now, I'll just add it again, but I don't need to, you know what I mean? I don't need to do anything other than...
Is async like replaces everything?
I mean, adds to the staging area. So it's like basically within the staging area, yeah, you won't see, it will be only one thing. Okay.
So I just commit that file before adding another thing if the two things are separated. If you have two files and I want to commit file A, but I already added file B, now it's too late. I cannot.
Yes, you can. Just like we saw this one. Yeah. So let's do it if you like. So okay. So by the way, what do we? Okay. Let's add this file.
I will ask it at the coffee
At the
break
okay. Yes. Yeah.
If it's a problem with
Yeah.
time, I mean.
Yeah, maybe we can keep on like iterating on this and do general exercises, but yes. So the thing is, if you really didn't want to lose the changes that you've prepared and apply them later, then that's the word that you pronounced earlier, which is about stashing. But I'm not teaching stashing today because it's too much. So the thing is, anyway, you can, because in Git, honestly, you can do pretty much everything. Then there are recommendations on, also if you collaborate, maybe you want to kind of agree on a certain way of doing things. Otherwise, it becomes like too confusing, too complex, or too convoluted. But there's always a way to re-add, remove, etc. Then do I recommend it? Maybe not always. Okay, so here, we already had something in the staging area, but we weren't happy quite yet, so we added other modifications, and we re-add those to the staging area, so that now there's no more difference between the working directory and the staging area, but this is not committed yet, so there's a difference between the staging area and the repository, and it's the addition of this line. So let's commit it. Explain expression. So now git log. Okay, I have 3 commits. I'm happy because I want to be able to do a bit of like moving around between, saying like 1 commit ago, 2 commits ago, etc. Oh yeah. Also, just so you know, so git log, you can if you want to display only the latest commit, you go -1. If you want to display the latest 2 commits, you go -2. Etc. etc. Yes, another important consideration is that Git is file-based. So really, when you git add, you're always adding a file, not a directory. In some cases, in some projects, that can be important because, for example, let's say, if I'm running some models, and those models will spit out some results, then maybe I want to save those results into a dedicated folder. Actually, that I recommend that you do this, that you would have a very well organized folder structure. So basically, in your project, so here you would have your programs, inputs if they are inputs, but maybe not, and then you want to save the results into a folder called results. And the thing is, you cannot do git add results because basically it doesn't do anything because it's a folder, it's not a file. So what you will see very often, but it's only a convention, is that people create files called .gitkeep. So within the folder of interest, you go like git keep, and this, if you add this is something that you can add and commit. So so what's important, why is it important? it's important because, for example, you know, if I have a big program, let's say not as trivial as converter.sh, but something that spits out files into results, into a results subfolder. Well, if the program doesn't find the results subfolder, it will error, and then maybe locally, so maybe you have the results subfolder, but when you share the GitHub repository, which we will see after the break, to a coworker, to a collaborator, then they will not get the results subfolder if it's not tracked one way or another, because again, Git doesn't see it, doesn't know about it. So the way to force the kind of carrying around the tracking of the result subfolder is to have at least one file inside of it, and let's say by default there's no file because I don't have results yet, so I just create this empty file that I create .gitkeep, which is like a habit convention, but really it could be called, you know, it could be called tracking, it could be, you know, whatever is convenient. That's just a convention. But let's say this is important for my collaborations. So I have this folder, which is pretext, where the file is only a pretext, but really what I care about is the folder. It's in the staging area, it's ready to be committed. So I'll go ahead and I'll create, add folder for outputs. And then I have an even longer history. Oh yeah, another nice option with git log is that you can write one line. Oops, excuse me. And instead of detailing all the authorship and date, etc., it displays each commit only on one line, just the commit ID and the commit message. And if you start from the bottom, you get this storytelling that I was telling you about, like first we converted file, then we added this, and okay. So maybe right before the break, I'll give you a challenge to do, which is going to be oh, maybe I didn't spend enough time showing you the checkout thing. So I'll just retype it here. So git. So the thing is, now the working directory is clean. So what's in the working directory matches what's in the staging area, which matches what's in the repository. But if I had been doing some messy things, just like sandboxing, trying out things, I would go like git checkout, take me back to so the file that I'm about to type, converter.sh, back to the latest commit head. Equivalently, I could write the commit ID. So like, sorry, I wanted to write the one-line version, so it can fit more on my screen. Git log one line. So instead of git checkout head, I could have written equivalently git checkout this guy. That's a relative way of referencing the latest commit, and that's like its absolute identifier. So your challenge is to display the converter.sh file as it was 2 commits ago. Actually, I don't know if the coffee break is at 2:30 or 2:35 or... Sì, ok. Perché ho chiesto a Luciana, però dopo non ha avuto la conferma, quindi... Ho chiesto a Luciana di farlo al 2:30. Ok. Sono tutti bravi.
No, se c'è un modo di farlo alla Python, per dire vuoi tornare alla versione più antica, fai add tipo -1.
Sì.
Secondo me lo si può fare. Ci ho mai provato.
No, ma il tilde vuol dire -1 già. È ciò che vuol dire.
Nel senso di tornare a quella originale.
Ah, sì,
quindi,
sì,
capito?
sì, tipo il primo. Ah,
Quello sarebbe figo.
ah.
Non c'ho mai
Sì, tipo, forse non lo so se c'è un identificatore relativo per il primo commit, tipo per contare dall'inizio.
Original,
Sì,
qualcosa del genere.
sì.
Cioè, non che alla fine fai one line e li vedi tutti e ti vai a
Sì.
prendere l'identificazione. In quel caso lì.
Sì.
O
E anche
addirittura-
perché nella vita reale normalmente tipo relativamente conti dal presente indietro
Certo,
e non
certo.
dall'inizio. Ma hai ragione che in teoria sì.
Magari vuoi tornare.
Sì,
Forse
sì.
con git reset riesci. No. Ah no, cioè
No, non lo so.
l'unico modo che mi verrebbe in mente è fare one line dei log e andarsi a prendere
Sì, è
l'identificativo.
assoluto in questo
Esatto,
caso, sì,
esatto.
il commit ID, sì. Mm.
Avete mangiato bene?
Sì, abbiamo preso la pizza. Non l'ho finita perché sono lentissima
Sì.
e anche abbiamo chiacchierato, quindi...
Giusto.
Però era buona. Sì.
Non è male. Molto tipica.
Mhm. E anche il posto è carino. Sì.
Molto trentino.
Sì, ecco, sì, come un chalet.
Esatto.
Do you have something?
The ID, like this.
Yes. So, can you show me your git log so that I can see that in
Okay.
You can do git log -- one line so that it displays in a compact way. Mm-hmm. And yeah, so you picked that one, right? The 609.
This one. Last
Oh,
one.
but okay, so that would be the first
Yeah.
commit, but my instruction is to display the converter 2 commits ago, yeah, not at the original commit.
But is it possible to go back once I go back down? Can
Yes.
I go back up?
Let's try it, because since there are so many several ways, let's try. So, yes, some people are afraid to lose their work, and they should be. It's a very healthy reflex. So, to go back 2 commits in the past, I'll use git checkout, like I've learned, head -2, and this is the file we're talking about. So now, when I display the contents of this file, yes, I am finding myself with this, I didn't have this like commented line at the end yet. But my history is still the same. So actually I haven't lost anything, So I can go back to the head over here, and you see that I haven't lost anything. So I'll say it, but don't do it. So if you really wanted to go back in the past and erase, so basically, right, what we're doing right now is like we are kind of traveling, we're going there and then coming back here, and we could go there, and we're just moving around this space that exists. But if I wanted to literally, for example, erase those 2 latest commit, and then this wouldn't change, but this would become my head in relative terms. Then I would use a command that starts with git reset hard. But I don't recommend it because you'd rather have too much extra work floating around than having lost work that you've done. So in any case, the general answer in Git about can I do this and could I do it this other way? It's like yes, you can always do it. There are several ways to do one thing, but some things are safer or more recommended than others. So in our case, by using checkout and moving around, we still have our 4 commits, and head still refers to the latest commit. Sorry. So our repositories here with all these stacks and with head here is still untouched. So I think we should go. Yeah, tell me.
Like after doing the checkout,
Yeah.
there's still, the file is still in the staging area here, from what I see.
Git status. Yeah. Yeah. Then it depends what we want to do with it. So. Oh wait. So I am back at the head. So I would have to. So I'm going to commits in the past. Yes, and now, well, since converter is now modified with respect to, and it is modified, so it's like basically we're not here anymore because we're here. So there's a difference here that we have to it depends what you want to do. So if you are really happier with that version of converter, then I would go like, git commit and make the informative message of, maybe in that case, that would be git commit, take program back to a non-broken version. Maybe that would be your commit message in this case. Maybe you just want to run a quick test, in which case, you do it by staying in this unclean working directory, and that's fine. It's more like we're here, actually. But, and then once you're done with your playing around or with your tests and your runs, you can decide to come back here or not. It's really up to you.
Okay, but if I commit after checkout, then is it going back?
No, it will create another commit. Yes, yeah, let's do it actually. Yeah. So, so what's that? So git status. I see that I have something to commit indeed. Okay, that's not a great commit message because precisely that doesn't really mean much in my context. And in your real computing case, it would have to correspond to for example, this change in variable broke something, or I don't know, decrease the performance. So maybe the commit message would mean something like recover initial performances, something meaningful like this. And now if I check the log, it does create another an additional commit. Let me display it as a one-liner. Git log one line. So I end up with a new commit. But let's say that the specific diffs, so if I run git show, of course I will find similarities in the sense that let's say the git show of this will be like the complementary of the git show for that, right? Do you have a question?
Yeah. What happens if I go back and then commit?
Yeah.
Where is master and where is head? Are they still in the same place?
No. So master, we are only on master today. So you're not leaving master in any case. Tomorrow we'll talk about branching, but for today we're not changing branches ever. So we're always on master. Yeah, it's so yeah, we're only moving in a one-dimension space. Yeah, so we're only there, and well, head corresponds to the latest commit. So as you see here, after checking out there, we actually technically it's like changing because it was a change with respect to head. So then we created that extra commit. So then it becomes like this. Okay, so let's get coffee and meet again in 20 minutes. Wait.
I managed to create a commit which is not linked to anything, but I don't
Oh,
know.
you're in a detached head?
Yeah, that's why I was asking, because I don't know how I did it.
Okay, it's okay. We'll fix it for you. Yeah.
Okay.
Get you-
Okay.
Yeah. It always happens statistically. Okay, pause.
Bisogna provarle poi ste robe, perché un conto è sentirle.
Perché se le così rimani, se non le così
So we will slowly resume. Yeah, so I'm glad some of you have already realized and understood the value in terms of backups and handling your own versions. What we will see next is even more valuable because collaboration comes into play. So basically, when you're not even the only one to be modifying a certain file, but imagine other people are, then that's like even trickier to keep track of. And again, Git, and in this case with GitHub as well, will help us do this. And maybe as an aside, I can also mention this because you're students and maybe after your PhD or even afterwards, maybe you'll be looking for jobs or you'll be taking jobs as an aside. Like, you know, I'm an independent researcher, data scientist, instructor trainer like you're seeing, consultant, etc. So I don't work in academia. I have worked in many startups, mostly in Canada, but also here in Europe. And being able to use Git is kind of like a prerequisite. So like if you're able to use, so you don't have to be the top Git user at all, you know. And you know, I'm very specific, and I hope, you know, I can convey a good foundation to your knowledge and your future mastery of Git. But at least having a working knowledge of the tool will help you out a great deal, because all startups in the high-tech sector use Git to keep track of the work and to collaborate. Okay, so one nice thing to mention to kind of refer also to what we saw this morning about text processing when, you know, for example, we learned grep. Well, guess what? Grep is also an option that you can use with gitlog. So for example, okay, as we know, gitlog here is not too impressive. If I display it in the wine line form, you know, I only have 5 commits, so it's really manageable. But you know, one day you're doing a big project and there's like 1,000 commits. So you cannot just manually, with your human eyes, find what seems interesting. So maybe you're interested in changes that regarded FASTA. Oh no, maybe it's that's in the commit message, I guess. Yes, so, okay, so when you use the option --grep FASTA, it will only return the commits where this word, in this case, was included in the commit message. So that can be very convenient. So that's like searching the content of the commit messages. Now, if you're searching for the content of the commits themselves, and this can, so I know horror stories, maybe back in the days when Git was not very popular yet, at least not in the universities, you know, people losing seriously like 1.5 years of their PhDs because there was a comma, let's say, instead of a dot in a C program. So things that are so frustrating and so stupid, and that could have been avoided, that would have taken 1 second to fix if only they had used Git. So if you want to know, you know, what variable was changed or introduced or removed, and you know that can be very useful in many use cases, you go like -s and you pass, so in this case, like let's say FASTA, and I see that, you know, that's about my that's the first commit that introduced it. Well, this one. And indeed, if I display it, git show, I see that, you know, it included the addition of something containing FASTA. But you know, that I could search for convert, and that returns the commit information about this commit, which indeed introduced convert here, in this case as a comment. But you know, for example, in your real-world scientific applications, you know, you start noticing a problem with, I don't know what the variable could be, but maybe cell temperature, and it's called cell temp, then you want to be able to locate when this variable was introduced and by who. So then you can accuse them. No, you can go and talk to them very nicely. I had written down another option. I forget what it is. What is the P?
So sorry,
Oh, yeah.
with S, we go to the first.
No. We don't. We go to get the commit that had this in the diff. So basically, so just as an aside, I introduced P just to display everything. So not just the commit metadata, but also like the actual content, like the equivalent of git show. So the minus P is doing the usual git log thing plus git show. And minus S is find me those commits where there was any editing with convert.
Sorry, and I didn't understand the difference between S and P.
No, okay, so P is only adding this part. It's adding the git show part. So when I run it without the P, I only get the metadata. I only get this. But if I want to like see exactly which code is concerned, so I see the diff basically, I have this in addition.
Okay, and so with S, we go to the
With S, we only select, so we're talking about filters here. So like in the grep idea, so except that grep enabled us to look into the commit messages. Now we're looking into the git, into the diffs, into the actual changes. Okay, now let's say if we wanted to run those, the script, bash converter, well, that wouldn't work because there are no FASTQ files in here. So what I may want to do, either I would change the path, but what I could do is I would copy the FASTQ files that I have, elsewhere, if I remember well. There must be under here. I'll copy all the FASTQ files. And now, of course, I can run this successfully. Oh, wait, sorry. In the CP, I forgot the destination. So in the CP command, that's the first argument is my source, and this is the destination. I want to copy them right here in the current directory. So now I'm able to run this bash program successfully. And I have created some FASTA files as a result. But maybe what I want to share with my colleagues are not those inputs and outputs in terms of data sets, but really it's just the bash program that they will be able to run on their own FASTA files or FASTQ files. Anyway, all this to say that I can tell Git, don't track those files specifically. So, by default, Git sees everything. So when I go like Git status, it tells me, well, there are all these untracked files. Oops. Wait, I have this, this little weird thing. I'll just remove it. But if it's like not meant to be tracked, notably because not meant to be shared or because I just want the flexibility of not depending on specific data sets, I can tell Git this through the git ignore file. So vim.git ignore. So this unless git keep, this is not just a convention. So this is meaningful to Git. Git will understand this in a specific way. So git ignore, and I want to tell them, I want to tell Git, well, basically ignore, so don't track, don't even bother looking at everything ending in FASTQ and FASTA. So here also you see that it's regex style, regular expression style. Okay, I'm saving this up. Now when I run git status, it's magical because you see this long output of all these untracked files. They don't show up anymore because we've told Git via this .gitignore file to not even try tracking those FASTA and FASTQ files. But the gitignore file itself, it needs to be tracked and needs to be a proper part of the repository, you know. So this one we want to add this one. .gitignore. Git diff, git. I think this won't show anything because. Oh yeah, right. So okay, we've added it to the staging area, but we haven't committed it yet. Now if we commit it. Ignore data files. Okay. Okay, if yeah, so among all these FASTQ files, let's say this one. So if I were to add it, you know, Git would tell me, well, no, it corresponds to the criteria, the patterns that I have in gitignore. They're ignored, so I'm not adding it. Now, if I really wanted to add it, if I really knew what I was doing, I would go like git add in the force option like this. Yeah. So maybe that's, for example, maybe you don't load your entire repositories with data sets, but maybe you want one data file so that a newcomer can run an example. So that can be a valid use case. So you can make an exception for one data file. But as you can see, Git is quite logical. Okay, now, so as you see, everything we've done here didn't depend on any online service. We were on the HPC cluster of the university, but we could have done all this locally. I mean, provided you have Git installed. But here I could have done just the exact same thing. Created a repository, created a directory, then initialized it as a Git repository, etc. So all this is like locally. So I have this repository just like in this very place, in this case on the cluster. Now, what if I wanted to share it with the world, publish it, get contributions from collaborators, etc.? So I would use a hosting service such as GitHub. So for those of you who have a GitHub account, I would invite you to connect to it now. So if you don't have one, I invite you to create a GitHub account to do the rest of the lesson. And you can be pretty private by selecting the hidden email address option. But if you don't want to, again, of course, I'm not going to force you. Oh no, oh maybe, okay, wait, I'll use another browser, maybe, I usually use Firefox, so, Okay, so I'm already logged in, and I use it for work, so you can see a bunch of things and activity. Yeah, by the way, GitHub by now it's almost like a social media, right? It's like the social media of programmers, so you can see activity. I never really look at it. You can follow people, start projects, and yeah, so like let's say that's my account, my profile, and yeah, that can kind of become your portfolio. So if you, I mean, actually you don't even need to try, because some companies have automatic scraping engines where like they crawl like all the GitHub profiles in the world, and you know, if they see that you've kind of done this kind of work, etc., they email you automatically and things like that. So I've received a lot of job offers just because I have a profile on GitHub. Okay, so what we're going to do, so we're going to use a web interface at the moment, and we're going to create a new repository with the same name as our, so that's where I'm a bit embarrassed to say local repository, because it's local, but it's on the cluster. So if we had done all the previous part of the lesson properly on our laptop, it would completely match. But yeah, now keep in mind that there's like, ultimately we will even have a version of our repository locally to demonstrate that it can be kind of shared easily. So let's create a new repository and give it the same name as our repository in our home of the HPC cluster. So it was called Genomics, if I remember well. Yes. Genomics. And here it's nice to give it a little description, but since this is a fake project, I'll go like HPC summer school, and I'll leave it public, and I'll go ahead and create repository. Is everyone able to follow along? So now what we have is basically we have like a remote version of our repository so we don't know exactly where it lives. We don't know where the servers of GitHub are, whereas for the HPC cluster, I think that, you know, at least there are some people in the university who know exactly physically where the servers run. And we want to synchronize. We're going to sync up, so this version remotely online on GitHub, which is empty so far, with everything we have in there. And as a reminder, in this repository, we don't just have those files here, which basically are the working directory. Thanks to the .git subfolder here, we have the entire history. So we are not just sharing a project, you know, as it is right now. It's like with all its past and all the versions where, as we have seen, it's possible to go back in time and back to the present. So here, actually, we can just follow the instructions. We will use HTTPS for today because it doesn't require extra setup, but in the future, I encourage you to use SSH. So create a new repository on the command line. Well, no, we have done this already. Or push an existing repository from the command line. Exactly. So we have an existing repository. So we're going to push it to the remote repository. And yeah, we'll get introduced to this language, pushing, pulling. So here, we can copy paste the instructions. Git remote add origin. So what does it mean? So Git, we're using the Git program. Remote, so remote is basically, you know, that it lives elsewhere, a distanza. And we're going to add a remote called origin by convention, and that's where it lives. So that's like a web address like you're familiar with. So I'm copying, pasting this. In your case, of course, it will be with your own username. And before I run it, maybe I'll just give you an idea that, so if I display git remote and even with the verbose option, I have nothing. So it means that in the moment, right now, so far, the repository is only local. It's not connected to any remote, so it doesn't sync up with other things. But the value of having it connected with remotes is that I'll be able to get contributions coming from elsewhere, and not just the work that I'm doing by myself when I'm logged in over here. So let's go ahead. And now when I run git remote -v, I see that, oh, now I have an output. So I have this remote origin that lives over there, and that we'll be able to push to. So the push command is git push. Then I specify the remote called origin, and I specify the branch. And as I mentioned earlier, we're only working on the master branch today. So now I have to use my ID and password for my GitHub account. So I have some stream over here. So yeah, it's been sending, transmitting all the content of my Git repository from here over there. So only what's part of the repository. So for example, as we know, the FASTQ files and the FASTA files are not part of the repository. So now if I go back to my web browser, and I'll just reload this page, because here, you know, I'm where the repository is supposed to live remotely. Wow, I get something. So I have, you know, this bash program that I'm versioning. I have this gitignore file that, as we've seen, is useful for deciding what to leave out of the tracking system. And I have this results folder, which, you know, artificially I decided to, you know, to illustrate the case where you want to make sure that a folder is part of a tree, a folder structure. And now, so as you've noticed, from the local original version of the repo, so yeah, repository for short, we often say repo in English, we pushed it to the remote. Now, what's in the remote? Let's try and pull it into where we are connected here. Git pull origin master. Well, it says already up to date, which makes sense because now there's no difference. Like, both places are at the same stage. But actually there's like by now, so this is very recent. When I started using GitHub, it was not like that. You have an online editor, so you can try it out for fun. I don't recommend it for real work, but like, let's say to fix a typo or something, you know, why not? Here you can click on edit, and you can type directly online as if this was Vim or something else. So for example, here, let me add this and now I can, so that's like a graphical version of everything we've learned at the command line. So the command line, we've learned how to, well, fire up a text editor to edit a text file. And then we've broken down all the steps here. But here it's like all this is kind of happening in a hidden way. I mean, just like when you double click a folder to open it, under the hood, the system is, at least a Unix system is doing CD folder name. But, graphical interfaces kind of abstract away those details for us. So here I'm going to do basically add and commit, but without seeing it explicitly. So here, what am I going to call it? So describe first processing step. And here I'm going to leave all these settings without touching anything. Is it readable, or we can make it larger? And I'm going to commit those changes using this graphical interface. So now that's what my file looks like. It has this extra line at the bottom. And we can navigate. So I'm showing you around because it's kind of a nice journey to take. GitHub is very well done. So the commits here are, just like when this is like doing git log, but displayed in a nice visual way. So that was the first commit with the commit IDs over here. When you click here, that does a copy that lets you copy paste the full commit ID. So for example, if I click this, and then I go back to my terminal and I go git show paste, I get this. It corresponds to that commit here, over there. Okay. If I do this one, the very last one, and I try to show it, it's not there, exactly. Fatal. So to be able to get it here, we have to, so like at the moment, the local and remote versions are not in sync anymore. So we want to sync them back. So here, I'm going to pull from the remote, git pull origin master. Okay, and I see that indeed there were some changes to bring over here, one file changed with one insertion. And if I try to git show this latest commit, now it's available. What else? Oh yeah, if I click this here, see, again, that's the same as git show, but in a nicer way, because you have some colors and it's a little less dry than what you get in a terminal. Yeah, and just so I personally use git at the command line as much as I take advantage of GitHub as well. But I know some people, either for personal choices or because their team works this way, like even when they work here, like changing files, writing code, etc., they don't use Git directly like this at the command line. They have graphical user interfaces. So like source tree, I forget the names because I don't use them myself. And there's absolutely nothing wrong with that. Like if you like them, if your colleagues work with them, if you're used to working with them, that's great. I just think that, for example, seeing the command line today together is always good to kind of clarify what's going on under the hood. But then, of course, feel free to use a nice graphical user interface with colors, with buttons. That's great. It's just that at least you know that under the hood, this is happening. Git add to the staging area and git commit to the repository. Okay. Yeah, so now we can try some collaboration. So maybe maybe I could give, so there are several ways to collaborate together. It will depend on whether you know the person very well. So like, okay, let's say I'll pick someone. So who wants to give me collaborative rights in their repository? So let's say you trust me. So who has a genomics repository like that and could add me here? Or maybe I'll add them. Let's say, okay, I'll do this. Who wants to be my collaborator? So here I'll add a collaborator. Hello. So who has a username, please? Yeah. MES. Right? No. Ah, sorry. Oh, that's you? Great. Okay. So you can also pair up and mimic the same thing. So let's say, so I'm the owner, and what's your first name, please? And Messei is my collaborator. So pair up, and one of you has to be the owner like me, and the other one has to be the collaborator like Messei. So I think you should receive an invitation over email, and you should accept it. Let me know if you don't receive the email. Okay, so you can accept my invitation, and then you will clone the project. So actually, because it would be better if we had like 2 computers, but okay, or maybe I'll just explain out loud when. So accept the invitation first.
Yeah, I already did that.
Oh, you already did?
Yes.
Okay, wonderful. So, okay, I'll just check that everyone is.
Okay.
So has
Dove per inglese, poi come fede, fade,
Fake.
Yes. Yes.
So has every collaborator accepted the invitation from the owner? And I will describe the steps as I do it with Messei, and if you're lost, of course, you can raise your hand, and Alberto will help you. So stay in the graphical interface for now.
Okay.
And so now I'm saying what the collaborator should be doing. Yeah, click on this arrow next to clone or download. Yeah, very good. We are in HTTPS, very good. And you will click this copy symbol, just like I showed you for the commit IDs, right? So the collaborator clones by copying this, basically it's a web address here. Okay, have you clicked it?
Yeah.
Yeah. And now the collaborator can go back into their terminal. Please check where you're at, so PWD, because we don't want to create something too messy. Okay, so you want to move out of there, and so I would say go back to your home. So CD into your home. Then I would say create a directory called collaboration. Say mkdir collaboration. Then CD into this collaboration directory. Okay, so now we know we don't have interferences with like other projects going on. And now you're going to do git clone and paste. Paste what you have copied to the clipboard. That's how it's called. Enter. And now when you CD into it, so CD genomics, you can run git remote -v. And you can see that the origin remote is directly there. And it should be github.com/the username of the owner /genomics. Yes.
Pensavo fosse un problema, c'ho un problema, se provo ad accedere a questo sito mi dice peer reports incompatible or unsupported.
Dove sei? Tu sei il collaboratore?
Sì, sì, ma pensavo fosse colpa di GitLab. Invece adesso con GitLab mi dice la stessa cosa. Me lo dà anche con GitLab.
Non.
Tutte le volte che provo a fare qualcosa, cioè anche se provo a fare un push.
Ah, ma sarà il tuo sistema allora, che forse è una security...
Mia.
sì, mi sembra specifica, perché non l'ho mai visto
Nemmeno
questo.
io. Nemmeno io.
Ma dici che l'hai già visto usando GitLab, facendo dei
Adesso in
push?
questo istante io ho provato a farla con GitLab e me lo dava. Avevo paura che fosse GitLab, per la storia che GitLab vuole le
Ah.
SH keys private. Però l'ho generato e mi dava lo stesso problema. Mi sono detto, vabbè, colpa mia. Mi sono messo su GitHub e me lo
Saranno
dà lo
dei
stesso.
settings di security,
Ma io ho
sembrano.
messo che
Ma...
gli host fanno, cioè io nel mio SSH config
Sì.
io ho messo control master yes.
Ma comunque usiamo HTTPS oggi.
Sì,
Facciamo...
sì, 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 sì.
quindi se
No, dico a prescindere.
sì, no, ma... perché...
Cioè non ho mai visto questo errore, io uso già Git male,
sì,
l'ho
sì,
scoperto
sì,
oggi,
sì,
però
sì.
non ho mai trovato questo, non ho mai visto questa roba.
Strano. Allora, ormai il collaboratore fa una modifica. Allora, veramente sentitevi liberi. Feel free to add a line to an existing file or add a new file. So my collaborator is supposed to work with you, right? And to help you make progress in your research. So please, collaborator, add something interesting to my work. So they themselves, they have to go through the, editing in the file editor, in the text editor, git status, git add, git status, git diff, git commit, etc. And they'll be able to push right back to the remote that's called origin, because that's the point of making them a collaborator on my repo. I have granted them this access, this write access. So let me know when you're done making an addition, making a contribution.
Can we store the password and the name for the GitHub locally so that we
So with SSH, so ultimately, like in the longer term, I would encourage you to use SSH. So anyway, you would have all this in your .ssh stuff locally anyway. So you wouldn't need to like type up the username and password all the time. But for today, yeah, it's, just this way I don't need to talk about SSH setup.
Probabilmente sì, c'è qualche errore. Allora no, adesso mi copio la chiave.
Yes.
Posso chiedere?
Sì,
Io avrei...
mi puoi dare del tu.
Ok. Io avrei, invece che GitHub, avevo già un account su
GitLab?
Bucket.
Ah, Bitbucket, sì, sì.
È uguale?
Ma sì, diciamo nel principio sì, quindi puoi altrettanto aggiungere collaboratori e fare dei... anche forse è meglio perché puoi fare dei repo, dei depositi privati gratuiti, invece su GitHub devi pagare per averne dei gratuiti. Ah, ormai?
quando Microsoft l'ha comprato.
Ah, non avevo seguito questa cosa.
L'hanno messi gratis.
Ah, ok. Comunque era possibile, tipo come studente era già possibile averne, ma ok. Ah, ok. Quindi,
Però comunque adesso
ah, ok, quindi anche su GitHub. Ok, ma quindi nel principio è la stessa cosa. Quindi diciamo che purtroppo l'unico vantaggio di GitHub è la massa critica, il fatto che siccome tutti ce l'hanno, allora, ma tipo con GitLab è interessante perché puoi fare un mirror di un account GitHub, quindi tipo puoi sfruttare la rete, tutta la gente già su GitHub e tipo, ma comunque usare GitLab per te, ma se GitHub non lo sa, Bitbucket non lo so se ti permette di fare un mirroring, non penso.
E quindi mi sono perso una piccola parte perché sto
Sì,
cercando di accedere.
certo.
Io ho la mia cartella Genomics
Sì.
per creare per metterlo su
Sì, allora, ma in realtà se lavori da perché allora io ti faccio un esempio, il mio account Bitbucket lo uso tipo per i miei backup personali, quindi in realtà non ho collaboratori, però comunque è utile avere questo log, eccetera. Quindi se vuoi lo puoi fare su Bitbucket in questo modo. Quindi vai su Bitbucket, solo che sono meno familiari con l'interfaccia, e crei un repository nuovo,
Ok, devo
che
crearlo da
sarà,
lì.
sì,
Poi.
però sarà vuoto. E di là ti prendi solo l'informazione SSH oppure HTTPS col path e da qui aggiungi una remote.
Ah, ok.
Quindi fai git add remote origin e copy paste il coso che hai trovato online
Ok.
e dopo puoi fare i push pull.
Perché io avevo creato dal sito, diciamo,
Sì,
la mia cartella
sì,
e poi l'avevo fatto
git clone. Allora, ma questo
Però non
sarebbe
sapevo
possibile.
si poteva fare il contrario.
Allora,
Fare
questo,
comunque.
tipo, se inizi veramente da zero, farei così, come hai detto. Però se già abbiamo qualcosina localmente, quello che fai, aggiungi la remote.
Perfetto.
Sì.
Grazie.
Allora, collaboratore, abbiamo qualcosa? Grazie. Scusa. So I'll refresh. Oh, 8 commits. So there's something that came up here, which, oh, I'm curious. What is it? It's, okay, it's the other file, very good. So in this case, I checked online, but I would give you as an advice, so that's a very basic collaborative workflow. Before I resume working on anything, so let's say, I'm starting my day, it's 9 a.m., I'm drinking coffee. So when I start work, it's always nice to run git status, but before doing anything, making sure that the working directory is clean, I'll go git pull origin master. Because maybe during the night or over the weekend or any time, some people, well, my collaborator in this case, and that's the case, has contributed something. So I don't want to start working if I'm out of sync. So I want to make sure that I'm in sync with whatever is shared remotely. Yay, so I'm getting this. And actually, even if my collaborator hadn't done anything, I would still encourage you to run git pull origin master. It's just that I would get the message already up to date, nothing to add. That would be fine, but that's like just a nice reflex to have in your fingers. Git pull origin master. And also because, since it's difficult to start working in the morning, at least you've run one command, so you're like, okay, slowly getting back into work mode. And now I can just start my own work, which I will add and commit and push when I'm happy and ready to share it with the world.
Excuse me. And if you forget to perform this synchronization before starting updating on your local copy, what happens when you try to merge the already performed modification by your collaborator with your ones? Is there some way to check for the date and time when they are queued or not?
Okay, so Git will do it for you actually. So of course it's better to avoid the situation, but yes, sometimes it happens. So actually, well, we can create the situation. So let's say I will ask my collaborator to make another change. So okay, let's do it. So what you did is you just added the demo file. Oh, and by the way, yeah, it's not a big deal, but you should write add demo file, not added. I mean, it depends on the conventions because let's say if everyone in your team, if everyone in your company is writing in the preterite, in the past tense, of course, don't listen to me and listen to them and do like they do. I think it's more standard to write at the imperative because, and also lots of, when I was telling you about the art of writing commit messages, so whatever, I'm very linguistic. I like these things, so I'm interested in it. So I've read a lot about it, and one way also to memorize it is to say it should be the completion of a sentence that starts with, if I apply this change set, this will. So this will, you know, add demo file, and not this will added demo file, but whatever, that's a detail. So we added this demo file. Let's say, you know, our brains are so in sync that you're like, oh, but you know, it's actually nicer to start the program with a comment that kind of describes what we're doing. So on your end, you will reopen this demo.sh file, and you will add a comment at the first line. And I will also do it, because I'm going to be like, okay, it's very nice to add a new program, but it's better if it starts with a description. So let's do it. So we're both working on it, and this will create a conflict, of course. Vim demo.sh. You can also mimic this in your teams.
If you write exactly the same thing, there will be two different commit ID, and the things will go out of sync because of different.
Yeah, true. So there are different levels, but so the thing is that if magically our brains are completely connected and then we write the same thing, which will not happen, but imagine it does, indeed it will be the same diff, but it will be a different commit ID. And the thing is, Git will be able to merge it automatically. So still, something will be happening, but I won't have to myself take care of timestamps or anything. Git will just see like, well, I see that there are two commits, but I can just merge them automatically because there is no actual conflict. There's no human choice to be made. But in our case, there will be a human choice to be made. So that's the more complex situation, but under the hood, there's this idea that the most it can, Git will handle it automatically. So I will call it to Git. Second line. Okay. Okay, so I'm not pushing, but that's kind of mimicking the situation where I just started my day forgetting to do git pull origin master. So I directly started work, started making my changes. So my collaborator, have you done the commit?
Yes.
And have you pushed it? Okay, thank you for asking, but okay, push it. So now, then I'll pull it and we'll see what happens. Okay. Okay, waiting for you. Okay, the 9th commit is in there. Add title. Okay, very good. So now I'll go. Well, okay, because there are two situations. I either could go like, oh wait, I forgot to pull, or I could even forget that and go all the way and push. So okay, I'll take the first situation. So, oh, by the way, I forgot to pull. So let's pull now, better late than never, right? So git pull origin master. Conflict. And then, so git tries to auto-merge. So basic, for example, if my collaborator, Missy, had edited a different file, actually our, if you like, the logs would have been out of sync, but Git is so good and so smart that it would have handled it. So it would be kind of transparent for me. So it would still be my mistake. So I mean, also that has an impact on work organization. So as much as Git is powerful and is a good tool, maybe you still want to be cautious and be like, okay, please just work on that part of the work because I'm going to do very tricky things with those other files. So, you know, I'd rather work on that. So like the way you separate your files and maybe organized in subfolders, that can also be a strategy to avoid conflicts. But, you know, let's take the situation where we haven't been able to avoid it, and unfortunately we haven't edited the same file and the same line. So what happens here is that the directory is not clean anymore, and it has conflicts. So we want to resolve conflicts. So I'm going to do manually. I'm the human, after all. You know, Git. You know, I said it's smart, but it's not smart. It doesn't have proper intelligence. Only I do because I'm a human being. So I will open up demo.sh, and this is how Git signals conflict. It uses these less than, equal, greater than. And here it's very visible because the file is short, but basically, let's say, imagine, so again, I wish you organized your work in a better way, but imagine you have a long file, like 1,000 lines, and it's full of conflicts. Then the way you will go about it to handle one conflict at a time is that, so in Vim, for example, we will search for all these characters, you know, and go to the next one, etc. And the choice, this convention was made because normally, you know, in any programming language or normal language, you don't see that many equals in a row. So that's like your sign for conflicts. So here, basically, I have to decide. I have to be like, okay, basically, my collaborator wrote check conflict. Okay, I think my comment is better. I'll make that choice. So basically, I will just edit the file the way I want it to be. So I will keep my line, remove his line, and remove those references. So and by the way, so this head refers to where I'm at. So that's my latest commit here in my copy of the repository, and this must be his commit, and we can check 7, yeah, exactly. So now I don't need those markers anymore. I'm removing them, and I'm saving this, and I need to commit this to clarify that this is the choice I made. So I go git commit resolve conflict in description or in title. Okay, and now I'm able to, push. Actually, I want to push it fast so that my collaborator can see that, you know. Oh, babe. Oh, sorry. I still have to pull then. Anyway, Git tells me because it's very well documented. So apparently, wait, to git pull.
I don't know if you added, did you add it, you modified?
Wait, no, and you have. Yeah, maybe I forgot to do git add. Yeah, right. Okay, wait. Let me check. Indeed. Okay, thank you very much. Okay. Yeah, otherwise the conflict should be locally fixed. So git add, the file in question was demo.sh. Maybe I don't want to retype this. Okay, now the commit is in there. And now if I git push, okay, wonderful. Okay, so What should, yeah, tell me, yeah.
Before describing the situation, you told that you performed the modification to the same file and to the same line.
Mm.
It means that if it were on different lines,
Yeah.
the conflict would have been solved automatically
Yes.
by...
Yeah, we can do it if you like. So, yeah, exactly.
Just
Specify, yeah.
specify that you said the same line.
Yeah, exactly. Yeah, so if, to be specific, it's not just the same line. I think there's some fuzzy matching going around. So it's like the whole, let's say if it was a for loop, it would not be just strictly this line. It would be kind of dependent on the lines around. Because for example, if, I don't know, like if I have a long code and like here I have an if block and here I have a for block, Git sees that, if I make small changes there, it reshifts the line. So if I had a whole block of something different, it doesn't compare line number 12 with line number 12 over there. It sees the patterns, right?
Okay.
So, but actually to complement on this point, that's what so I wanted to highlight this point so that basically when I do git pull origin master, Git tries to merge automatically whatever things it sees, and it spits out conflict only if it wasn't able to do it. But if if his changes and my changes were affecting different parts of the code, here after auto merging, instead of having conflict, you would have auto merge successful. Now I'm a bit hesitant on the timing. Maybe I would like you to practice a bit on this, but okay, maybe I'll show you another collaborative scenario. So that's like a basic workflow for collaborating with your student, your stagiaire, your advisor, etc. But now I also I would like to illustrate another scenario, which is also very nice, also in terms of building the community of free libre open source software. And then I'll let you play around and I'll walk around to answer your questions. So let's say the other situation is that unlike Messe, who is my friend, I will pretend that one of you here I don't know. So who wants to share their username with me? Who just created the genomics file? Yeah.
Okay. B-I-N-A-Y-A-K.
B-I-M-A-Y. Like this? No. I know, but it doesn't.
Maybe you just use your name like this. Mine is super complex.
Okay.
Yeah, it goes on and on.
Eleonora? Isotta?
Lisotta or Isotta?
ISO-WTA.
No, ho messo la L. Okay. So, so let's pretend that we've never met. Maybe you live on the other side of the planet. So there is this great scientist, Eleonora Isotta. Purtroppo non la conosco personalmente. So I see that she has done this like great work in genomics, and I'm really interested in it. And I don't want to just use it, but I also want to contribute back. So in this case, what I'll do is that, I mean, like if I email her and I'm like, can you please add me as a collaborator? First of all, I don't think that she would accept, and also I don't think that she should accept because she doesn't know me at all. Or maybe actually, then if she goes into my GitHub profile and she sees that I'm a good contributor, etc., I don't know. But let's say in the general case, there's no reason I can get this privilege of becoming her collaborator on this repo. So what I will do is something different now. I'm going to fork her repository. So I'll create a fork here, okay, as myself. Oh, yeah, okay. So it's calling it Genomics 1 because I already have a repository called Genomics. But okay, whatever. Apart from this detail, here I'm keeping track of all the information. So it's forked from her repository. And now that I am on my fork, since it's mine, so I'm the owner, I'll be able to push and pull as I wish. Whereas on her repository, of course I can pull, but I cannot push, because otherwise, random people could write in your own projects and that wouldn't make any sense. So I'm going to work on my fork of her repository. So here I'm, see, that's my username, so I'm the owner. I will copy to the clipboard this thing. And here locally, I will clone it. Git clone, and I'm copy pasting this. So now when I cd into it, and I display the remotes, oh, excuse me, I see that so like when you clone an existing repository that you got from online, by default, the remote is called origin. And by convention, we call upstream the gatekeeper. If you want the, how to say it? Tipo, Eleonora è autorevole, io invece non sono nessuno. So you have like the kind of official project, and that's like very relevant in, let's say, established projects. So for example, I don't know if you run Python, you probably use the library called NumPy. So NumPy is very important software, very precious and very big. So it's not like tomorrow I can show up and I can just like add code into it. Of course not. So if I want to work on it, I will fork it, just like what I did with Eleonora's work. And then my fork, will be the remote origin, and the official NumPy repository will be called upstream. So that's this idea of, ecco perché ho detto autorevole, è un po' il punto di riferimento. So origin comes by itself when I clone, whereas if I want to specify that the upstream is this work, this repository over here, I'll get this, so wait, I'll use this. I'll get this place over here, and I'll go like git remote add upstream. So in theory I could call it something else. I could call it Eleonora. I could call it workshop, summer school. I mean, I could call it whatever means something to me. But again, like in a typical scenario where, let's say, there's a big official established project and me, a tiny collaborator, your remote will be called origin, and this authority will be called upstream, basically. So now if I display git remote -v, I see that I have two remotes, one origin, which is where I'm the owner, and one upstream, where I can pull from, but I cannot push to. So here we have more of the notion of a triangle, because look, if I try to push to upstream, git push upstream master, this is denied, because I don't have permission to write there, unless like Eleonora would have to give me explicit permission for me. But I can always pull from there. As long as her repository remains public, I can always pull from it. But I can push to my own remote, so I can push to origin master. Oh, I think I didn't type properly. Okay, nothing to push. And of course I can also pull except that typically this is not going to be very interesting because there's not going to be, I mean, unless, you know, maybe if I used the online editor, maybe, yeah, like I could, for example, here I could use the interface to go like add readme and can preview it. So the language here is marked down. I also, not that you have to learn it by heart or anything, but like it's very convenient to be able to write Markdown because it's can be read by humans and by computers alike. So you know, like level 1 headers are with a hash, level 2 headers are double slash, etc., etc. And you can write lists like this. You know, item 1, item 2, like this. So yeah, create a README file. And I'll commit to master. So obviously this is the origin remote. Otherwise I wouldn't have permission to just like edit things like this. So in this case, running git pull origin master means something because indeed something happened remotely and I want to get it locally over here. So see the addition of the README over here. And the way I would collaborate the way I would collaborate with Eleonora, who doesn't know me personally, is through the mechanism of a pull request. So, okay, I'm sorry, I'm aware that I'm going a little fast over here. If you've never done it, that might be a little confusing, but you know, at least you've seen it once. You know, like I've used GitHub for many, many years and I'm still learning a few things. So it's like, I don't expect you to like be super fluent in Git and GitHub, you know, by tonight, but at least you're seeing it, and even throughout the summer school, maybe you'll use it and gradually you'll pick up all the elements. So when I visit the upstream repository, I can decide to create a pull request. So that's going to be a mechanism to propose my changes to her. So here I need to compare across forks because there's like her repository and my fork of her repository. And here, so this is, yeah, okay. So also here, what's happening under the hood is actually a check of the auto merge thing. It's similar, like Git under the hood is making sure that even if it's the same file or even if it's the same line, it's mergeable together or not. So here in the future, so like tomorrow when we see branching, you'll see that maybe there's something also to select over here. For today, since we're only working on master branches, master doesn't change. But basically, you see the arrow here? I want to like suggest what's in here, which is basically the addition of this README file into her original work. So of course I'm going to be very nice. So she accepts my changes. I thought we could add README for this project. What do you think? And here it's also Markdown, even though like Markdown has many flavors, so GitHub Markdown is a little different from other Markdown, but like roughly speaking, it's very simple anyway. And I will leave this. So the thing is, like GitHub has become so much. It's so full of features. Like with respect to like when I started using it in 2012, you didn't have all these options. So in a way, it was easier to teach because by now it's like everything I feel I have to explain, otherwise it looks too magical or too arbitrary. But I would say, at least at first, just like leave the defaults as they are. Basically, that's leaving Eleonora the flexibility to maybe take my changes or part of them or remodify my changes. Whereas if I don't check it, it would mean basically take all or nothing. You know, that's what I'm offering. If you don't like it, you say no. If you like it, you say yes, but there's no in between. Whereas if I leave this checked, it allows for the flexibility. And for example, you know, if you ever contribute to NumPy or a big project like that, there are chances that this would be relevant, because even if your work is good, there's always like a tiny thing that you know, you didn't do their style. So it's worth, I think it's worth leaving it checked. And now I'll create a pull request. And now Eleonora should receive a notification. Maybe in her emails, depending on her settings, but at least like if she visits this place, so if from her genomics repository she goes into pull request, and you can see there's one here waiting. Over here she can decide, so first of all, here you see we have all these discussion boxes so we can interact. Maybe she's going to be like, oh, thank you, but can you also add this or that, or, but you know, in general, I would say, you know, if the pull request is, even if it's not perfect, but if it's improving what you had, I would encourage you to accept it. So if she likes it, she can, so I cannot show it to you because I don't have the rights to merge it, but the action that she would take to accept my changes is called a merge. So I think if she merges it, we'll see an update here. So scroll down a little bit here, so you can merge pull request this way and then confirm merge. See, did you see what it appeared? So instantly. So the pull request is now closed because it was merged. I mean, it could also be closed if deemed irrelevant. If she was like, no thank you, instead of merging, she would just like close it, but my code wouldn't get into her code. And yes, so now that my pull request is merged, basically I can sync back with, so let me show you the log. So right now I am on my fork, on branch master anyway, I'm not leaving the master branch, and the latest commit is my contribution of creating a README. So typically here, just like before in the basic collaborative workflow, I said, you know, always do git pull origin master before starting your work, because you don't know, maybe some changes have happened overnight. In this case, some changes might have happened not in origin, because origin is just me, so I would know it if it happened, but upstream, because even maybe it's a very big project with 1,000 contributors. So I would go like git pull upstream master. And if I want, I can sync up my, I can git push origin master to make sure that what I have here is the same as what I have there. I would say there's no rush to do this, but why not? And when I run git log, here I see that on top, so after my contribution, there's an extra commit, which is a bit special because not really bringing a change. It's the merge commit. So by default, when you merge, it creates a commit. Can I do it other way? Yes, I can, but whatever. Let's keep it simple for today. Yeah. So basically, let's say in spirit, in this, so maybe I would not even call it collaborative workflow, but more contribution workflow. In the contribution workflow, you know, you work here locally, and you pull from upstream and you push to origin. And then, so once you've done work here and pushed on origin, the way to suggest your changes is via the mechanism of a pull request. You submit a pull request. And whether your pull request is accepted or rejected, you want to pull back from there anyway, because that's where the reference work is happening. Okay, so now when you pair, instead of being owner-collaborator, let's be, one is the authoritative original author owner, and the other one is like me, the nobody who tries to get a contribution to the main project. So maybe if you like now, you can be the nobody, since you were the the authority before. You can closer if you like. You can get up and.
No, esatto, ma ho fatto, vabbè, come vuoi. Perché non è tornati indietro, perché poi non ho fatto il male. Ma perché l'ho già fatto per quello, l'ho già fatto interessante. Lo faccio da solo. Io sono QE, Git, non Dev, e me lo faccio da solo. Perché lavoro da
Tutto bene?
Sì, tutto bene.
Hai già usato Git?
Sì,
Ok.
anche in repository.
Ah, ok.
Ho imparato a hidden, che non sapevo.
Ah, sì, ok. Bene, sì, meglio così, sì.
Non ho fatto la parte di pairing
Ok.
con qualcuno, però magari ora lo faccio.
Comunque c'è tutto il materiale online di questa lezione.
Sì,
No, sul sito delle Carpentries, tipo se cerchi software carpentry, I can type it here for you.
Ah no, ce l'ho la mia versione, no. Sì, ce l'ho la versione. Sì, ora lo cerco e vedo solo
Ma tu sai, certo io non ho mai editato i ritmi in Ingegneria, devo imparare anche a fare quello.
Sì, sono utili.
Infatti.
Perché è molto più piacevole quando arrivi su un progetto e c'è un piccolo readme, delle istruzioni di base per il setup, eccetera.
Quindi così ecco, sono diversi. Ah no.
Sì, quindi se cerchi questo online trovi le lezioni e te le puoi studiare da solo. Cioè.
Grazie mille.
Prego.
Sì, è da qua. 2 volte? Ah, ok, quindi diversi
No, il corso di Bayesian.
Allora, devo dire che questo l'ho un po' mischiato con varie fonti, quindi. Ma se vuoi. Allora.
No, è solo per
No,
dire
ma.
molto carino.
Ti è piaciuto? Ok.
Ho visto qualcosa di Python, NumPy, come si chiamano i notebook creati.
Ah, Jupyter, sì, 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 Jupyter, sì. Ok.
Magari la prenderò come spunto per qualche corso
Bene,
ulteriore.
sì, sì. Mm.
Grazie.
Prego. So, any pull request successfully submitted, successfully merged?
Beh,
Come?
Questo qui dov'è?
Allora, scroll down a little bit. Sì, la prima, version control with Git, quella qui, sito. Sì.
Ah, ok. Un'altra cosa.
Sì.
Io ho il dubbio
Mhm.
che anni fa i colleghi abbiano messo un software che io distribuivo su GitHub, però non so se mi hanno fatto un account mio
Ah,
o se l'hanno messo su quello come faccio a vedere se ho un altro,
dell'organizzazione.
perché adesso ne ho fatto uno, ho fatto questo.
Ah, ma
Non
io
volevo-
cercherei
non-
nelle mie mail, io cercherei
Sì,
GitHub nelle mail
ho già
perché
cercato,
comunque
ma non ho capito cosa ho fatto.
non ci sono le notifiche, perché tipo
No, probabilmente l'ha messo sul suo.
ah, perché comunque se l'account anche organizzativo non è legato alla tua mail, non è
No,
cioè,
probabilmente perché adesso qua quando io l'ho creato ho ricevuto una serie di. Sì, ho ricevuto queste cose qua, no? Queste notifiche che ho
Sì.
indietro non ho trovato.
Ah,
Mi era venuto il
ok.
dubbio perché quando l'ho creato ho provato con Alberto.Bellin e
Esisteva già?
mi diceva che era già
Ah.
usato, magari c'era un altro che ne
Ah no,
so.
ma comunque si vede, allora, perché se andiamo su github.com e si scrive lo username,
Questo è quello che ho aperto adesso.
ok, ma quello di prima, tipo quello sospettoso,
No, quando ho creato questo, quando ho
sì,
messo
sì, sì, sì.
cosa mi ha detto che c'era già.
Sì, allora cerchiamolo, così lo vediamo e vediamo cosa sono.
Non so.
Sì, allora github.com/ e lo username. Sì,
semplicemente,
ecco,
ok,
sì.
sì, giusto.
Ah, ecco.
Basta così,
Sì. Mm,
non c'è.
allora
Forse
non
voleva il
esiste.
punto, forse non voleva
Ah,
il punto.
sì, giusto, sì, sì.
Ok,
Secondo me
allora
non è valido. Sì, ecco.
Ok, allora vuol dire che non c'è.
Mm, mm,
Ok, grazie.
mm. Ah, ops, sta andando bene.
Io lo sto già usando da un po'. E la cosa che mi ritrovo spesso a fare è che io sto modificando il mio branch
Sì.
e poi dopo un po' mi accorgo che l'upstream è cambiato, no?
Ah, sì,
Ok.
certo.
Quindi
sì, sì.
qual è la cosa che mi conviene fare in questi casi? A parte chiaramente devo metterci mano e controllare che i miei cambiamenti siano
Mm-mm.
compatibili con quelli dell'upstream.
Sì,
manualmente come lo faccio?
ma allora ci sono due considerazioni che prima, allora almeno nel mondo dello sviluppo software è molto di moda fare short-lived branches, quindi
Ok.
quando crei una branch non te la tieni per mesi, settimane, eccetera,
Ma cerchi
fai
di-
il tuo cambio, sì, e cerchi di ottenere un merge
Ok.
e fai un cambiamento piccolo
ogni volta.
e quindi sei più o meno sempre in sync col master. Quindi già questo è un po' queste storie di avere una dev branch che vive di là e tre branch in parallelo non vengono tanto di moda, non vanno più di moda, però comunque in teoria perché no? E quindi direi di fare dei merge frequenti.
Con
Quindi
l'upstream.
sì, sì, così mantieni la compatibilità.
Ok.
Quindi anche se lavori così in parallelo e anche perché a volte diventa un problema anche di tipo perché i package sono updated, eccetera, eccetera, quindi devi un po' tenerti aggiornato così. E quando allora, in realtà un git pull, allora, tipo sei nella tua branch, tipo si chiama dev, non lo so.
Sì, io tengo sempre solo la master comunque. Anche della
Ah,
mia.
ok, quindi allora stai lavorando sul tuo master e quella dell'upstream sta cambiando. Quindi tu prima di lavorare, quando hai un working directory pulito, allora se fai git pull upstream master,
Sì, come abbiamo detto
in realtà
prima.
ciò che sì, nei dettagli fa un fetch e un merge.
Ok.
Perché rigorosamente si dovrebbe fare in due tappe. Prima il fetch che ti prendi ciò che esiste nell'upstream, ma non fa il merge con quello che hai localmente.
Ok.
E quindi tipo anche prima e se fossi molto molto rigoroso, tipo faresti prima il fetch, dopo controlleresti la differenza tra questa
Quello che ho io.
upstream master e il tuo origin master e dopo decideresti di fare il git merge e così
Ok.
faresti git merge git merge upstream slash master. Quindi questo sarebbe veramente il modo super pulito, nel senso che deciso esattamente cosa, quando voglio prendere i cambiamenti dell'upstream.
Ok, capito. Facendolo frequentemente, però insomma, più lo si fa spesso, meno succedono cose, diciamo, involute. Quindi a questo punto se io volessi fare tra virgolette, un rebase, non so se si chiami così, nel senso annullare quello che è la mia in questo momento e ricominciare dallo stato dell'upstream,
Sì, è
mi
un
conviene
rebase,
cancellare e
sì.
rifare o posso farlo?
No, allora, ovviamente questo è molto troppo avanzato per oggi, ma ne possiamo parlare così. Quindi quello che ho bisogno di un disegno per...
Vedo se ho qualcosa.
Ah, forse anch'io ho la carta. E la penna, forse. Grazie.
Cioè, io poi uso un'interfaccia grafica, come dicevi tu, ogni tanto, giusto per capirmi. Ma
Sì, va bene, sì. Quindi diciamo che questo è l'upstream master, o almeno il punto di riferimento che non dipende da te.
Sì,
Quindi
ok.
l'upstream master e tu ad un certo punto,
Ho
quindi
fatto il
forse,
fork.
ecco, quindi
Ok.
in passato sei partito
Esatto, sì.
di là e hai fatto i lavori tuoi, così.
Sì, esatto.
E nel frattempo questo è andato avanti e ti accorgi ad un certo punto che tipo anche il tempo è passato, forse tu sei rimasto lì, ma forse anche hai toccato delle cose che loro non hanno toccato, quindi non c'è un conflitto tipo ciò che abbiamo visto prima, ma se sia per sottoporre una pull request che per essere aggiornato localmente, ciò che vuoi fare è più o meno ripartire dal head lì e quindi questo spostarlo, non so come rappresentarlo facendo delle frecce forse, ma questa cosa, ma la stessa, metterla di qua. Ma immaginiamo che sono gli stessi,
tenendo
capisci?
possibilmente alcuni dei miei cambiamenti che non sono in conflitto con questa versione.
Non a tutti, comunque diciamo se ci sono conflitti troverai ciò che abbiamo visto prima,
Sì.
quindi questi simboli
Ok.
e dopo deciderai cosa vuoi fare con loro. Ma diciamo che vuoi portare questi cambiamenti che avevano per origine
Tutto ciò che
questo.
mi sono perso qui alla mia versione.
Sì, e comunque e allora se non c'è conflitto, tipo tendenzialmente non hai cambiato gli stessi file, quindi non c'è conflitto, e quindi il diff sono tipo le stesse cose, però quando fai questo il problema è che crei dei nuovi commit, quindi tipo ciò che si chiamava qui, non so, C4D, tutto questo viene richiamato, hai una nuova serie di identificatori, e quindi in realtà hai cancellato
Questi
il
commit sono
passato.
nuovi commit sulla versione sull'head.
Sì, sì.
Ok.
E quindi si chiama history rewriting, nel senso che hai cancellato queste cose del passato che avevi fatto per davvero, e hai messo al posto loro queste nuove cose, ma direi che ti trovi in posizione migliore per sottoporre la pull request
Sì.
a questo punto.
Ok. E questo,
E
nella
questo
pratica
si fa così con git rebase. Allora, diciamo che prima, quindi immaginiamo, allora faccio, mi assicuro di essere sul brand, allora localmente vado su master,
Se vuoi lo proviamo subito anche tanto.
sì,
insomma.
quindi fai git checkout master, qui fai il git pull upstream master, quindi hai l'ultimo master dell'autorità.
Primo con slash
No,
upstream master.
Sì.
Adesso devo vedere se l'ho settato perché ok, non l'avevo settato.
puoi mostrarmi il git remote per vedere? Git remote -v. Ah sì, vedi, hai solo l'origin,
Ok,
quindi hai solo il
devo fare
tuo.
questa cosa qua.
Quindi devi fare
con-
git remote add upstream, sì.
con l'originale.
Sì.
No, it's not necessary. I mean, in case delete the fork, so you were forking my project, then
We did most of this.
amplified, and I accept your pull request. So the meaning of the fork runs. Because you can even clone the entire record.
Yeah, I get if you're working like on a collaborative project, then
Hai un carattere strano qui.
Questo cosa fa?
Ma puoi fare CTRL A.
like the conflict then
Un attimo che cerco il path di questo.
Tendenzialmente non servono i quote, le virgolette.
Ah, del...
Ah no, ma non devi fare così. No, 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 vai, clicca su
Sì.
questo e fai qui
Sì.
e copi questo.
Ah, tutto quanto.
Sì.
Ok. Quindi tolgo i quote,
Sì.
faccio
Sì,
così.
così.
Quindi questo è l'upstream
Sì.
che... Ok.
Already exists. Ah,
Strano.
dimostra ancora git remote add? O git remote, sì. Ma perché avevi eseguito il tuo, la bozza,
Ah.
quello con path, quindi devi toglierla prima. Sì,
Prima ho sentito Gianfranco, domani credo che venga lui.
sì.
Poi gli dico anche di sentire per i giorni successivi, vabbè tu non ci sarai.
No, ma anche Alberto, siamo qui domani, ma dopo non ci siamo più. E domani decide lui cosa si fa, quindi...
Penso che venga qua Gianfranco.
Ok, perfetto. Grazie
Allora è stato
comunque.
un piacere.
Sì, anche
Alla
per
prossima.
me. Ciao.
Grazie.
Grazie.
Domani.
A domani.
Vedere anch'io. A domani.
Ok, grazie, a domani.
Si può fare un remove, non esiste.
Git, git remote remove. Non lo conosco a memoria.
Sì,
che
ok,
hai-
adesso immagino che andrà.
E
nel nome,
upstream?
vabbè.
No, non ci sono le virgolette. Prova. Ma se no lo cerchiamo online. Ah sì, sembra di aver funzionato, no?
Vediamo.
O-
Ok,
Ah,
perfetto,
ok,
quindi
bene.
adesso
Grazie.
la penna. A domani, grazie.
Grazie mille ancora.
Grazie, a domani.
Perfetto, ok.
Ok.
Quindi adesso